Hello students, today we are going to revise the chapter motion and also force and laws of motion. So there are two chapters that we are going to revise today, which are chapter number 8 and 9. So starting with MCQs, of course most of the questions are MCQs only, and together we are going to solve these MCQs. So first question, in which of the following cases of motions the distance moved and the magnitude of displacement are equal? I will repeat the question. In which of the following cases of motions the distance moved and the magnitude of displacement are equal? The options are: if the car is moving on a straight road, if the car is moving in circular path, the pendulum is moving to and fro, the earth is revolving around sun. So if the car is moving on straight road, yes, the chances are that the displacement and distance are equal. Option B, if car is moving in circular path. Remember students, that in circular path direction keeps on changing, so velocity also changes. So this is the accelerated motion. Then pendulum, the object comes onto the same point again and again, so displacement becomes zero. Earth is revolving around sun, this is also very close to the circular path. So obviously the option A, which is if car is moving on a straight road, this one is a correct option, because here the chances are more that distance and magnitude of displacement are equal. So A should be the correct answer. Let us move on to the next question. Second question. A boy goes from point A to B with the velocity of 20 meters per minute and comes back from B to A with the velocity of 30 meters per minute. The average velocity of the boy during the whole journey is. You have to find average velocity. Okay, so when boy goes from point A to B, his velocity is 20 meters per minute, whereas when he comes back, his velocity is 30 meters per minute. Options are 24 meters per minute, 25 meters per second, 0, and D is 20 meters per minute. So this is difficult one. We have to solve this and then we will come up with the answer. So let us solve this. Remember that distance has not changed. Distance is going to be same. Okay. But time is going to change because velocity is changing. So the correct answer is 24 meters per minute. But then there should be certain explanation why 24 meters per minute. Option A is correct. Why it is correct? Let us try to explain it mathematically. The formula for speed is distance upon time, as we all know. Okay, speed is equal to distance upon time. Then if 20 minutes per minute is the initial velocity or initial speed, then that 20 is equal to d upon t1, where t1 is what? The time for a boy to reach point B from point A, and d is the distance, right? So talking about the speed, 20 is equal to d upon t1, and then t1 is equal to d upon 20. Sorry for the disturbance. t1 is equal to d upon 20. That is value for time from point A to point B. Then similarly for 30 minutes per minute, d upon t2, because t2 is the time required for a boy to reach point A from point B. Okay, so therefore t2 will be d upon 30. So time t2 is what? A boy to reach point B from point A. So t2 is equal to d upon 30. Now average speed. What is average speed? Total distance upon total time. So what is the total distance between point A to B and back to point A from B? Total distance will be d plus d, that is 2d. So this will be 2d divided by total time. So total time is d upon 20 plus d upon 30. So both of this will be the total time. So d upon 20 plus d upon 30. Well, now you have to solve this. Now remember that d can be is a common in numerator and denominator, so you can take it outside. Okay, so d will get cancelled. Then what remains is 2 divided by 1 upon 20 plus 1 upon 30. Then you have to cross multiply this, or you can take LCM also. Now after taking LCM, what I will get is 20 plus 30 divided by 20 into 30. 20 into 30 is what? 600. 20 plus 30 is what? 50. Now I will simplify this. And simplifying, 20 plus 30 will give me 50, and 20 into 30 will give me 600. And then cancelling 1 0 from both the sides, numerator as well as denominator. 2 into 60 is what? 2 into 60 is, so let us simplify this after cancelling zeros. 5 ones are 5, 5 12s are 60, and 2 into 12 is what? 2 into 12 is 24. So that gives me the answer, 24 meters. It should be 24 minute, not meters per second. It should be what? 24 meters per minute, because that is your unit for this particular problem. So here by mistake it is meters per second, it should be meters per minute. So the correct answer is, let me switch back. So the correct answer is 24 meters per minute. That is your correct answer. Well, so I hope you understood the explanation that I gave. Let us move on to the next question. Velocity time graph of the object is given below. So this is the velocity time graph. Object has uniform velocity, uniform speed, uniform retardation, and variable acceleration. Remember that this is a straight line, so the acceleration is uniform, but the velocity is decreasing, so it should be uniform retardation. So what is the correct answer? C, uniform retardation. Let us see the next question, fourth one. Which one of the following graph shows the object is stationary? Stationary, it means that position is not changing, so it should be a straight horizontal line. So which one is the correct one? B is the correct one, where position is not changing throughout the time. So B option is correct. According to the given velocity time graph, this is your velocity time graph. The object is moving with uniform velocity, has some initial velocity, is moving uniformly with some initial velocity, is at rest. So option A is moving with uniform velocity. This should not be correct. Why? Because this is velocity versus time graph. So you can talk about acceleration. If I want to talk about acceleration, I can say this is a straight line, so it should be uniform acceleration. But definitely this is not uniform velocity, because this is velocity versus time graph. That's why. B has some initial velocity, that we can say, because yes, it is starting not from origin, so it has some initial velocity. Then option C is moving uniformly with some initial velocity. Again, you cannot talk that it is uniform motion. Why? Because this is velocity versus time graph. Okay, velocity is changing, acceleration is uniform but not the velocity, so definitely not C. And D is at rest. This is also not true, because in D, if it is rest, then the graph is not like this for rest, object at rest. It is a straight horizontal line, that too for position versus time graph. So definitely not D. So correct answer is B. B is the correct answer, has some initial velocity. Question 6. Which of the following is an incorrect statement? You have to find out the incorrect statement. Mass is a measure of inertia of the body. This is true. It is correct statement. But you have to find incorrect statement. Newton's first law is the law of inertia. It is also correct. Unbalanced force produces constant velocity. This is not possible. If you are applying unbalanced force, then it won't produce constant velocity. Newton's third law talks about direction of the force. No, not only direction. It is true because yes, there is a direction also, because it is in opposite direction. So D is correct, A is correct, B is correct, only C is incorrect statement. So the correct option is C. Unbalanced force produces constant velocity. This is true because it is an incorrect statement. Next question, question number 7. According to third law of motion, action and reaction always acts on the same body, always acts on different bodies in opposite directions, have same magnitude and directions, acts on either body at normal to each other. Now the correct for this is it always acts on different bodies, because if there are two bodies A and B, then A will apply force on B and B will apply force on A, and also direction is opposite. So the correct option should be B. Next question, question number 8. A goalkeeper in a game of football pulls his hand backward after holding the ball. This enables the goalkeeper to. Now remember that ball has some mass, it is moving with some velocity, where velocity is changing. So obviously here momentum is the key point that you have to concentrate on. So option A is exerts large force on the ball, reduces force exerted by the ball on the hands, increase the rate of change of momentum, and decrease the rate of change of momentum. Remember, there is mass and velocity, so we should think of the momentum, and obviously goalkeeper will try to reduce the momentum because he has to reduce the impact. So option D is correct. Okay, decrease the rate of change of momentum. Ninth question. The inertia of the body tends to cause the object to increase its speed, to decrease its speeds, to resist any change in its state of motion, to decelerate due to friction. So what do you think? What does inertia tends to cause? It tries to resist any change in the state of motion. So the answer is C, to resist any change in its state of motion. Last but not the least, a passenger in a moving train tosses a coin which falls behind him. So it means that motion of the train is accelerated, uniform, retarded, or along the circular track. Circular track, it doesn't have any, they have not said anything about circular thing. Uniform, not possible, because coin would have then fall on the same position in his same hands, but that doesn't happen. It is falling backwards, falling behind, and this happens when there is an acceleration, not a retardation. So the correct answer is A, accelerated motion. Now comes homework for you. These are true or false statements, very easy to answer. Please try out this at home. Displacement can be 0 but distance never. Second, displacement magnitude can be greater than distance traveled by the object. C, time is a vector quantity. Fourth, if the velocity of the body decreases with time, the acceleration is negative, and motion is called decelerated motion. You have to think whether it is true or false. And question 5 is, as per Newton's third law of motion, FAB is equal to F is equal to minus FB. Remember that FAB means force applied by A on B. Okay, whereas minus FB is force applied backward from B to A. So it minus sign means they are opposite, but magnitude is same. So I have to think whether it is true or false. Well, that was all for today. Thanks for attending this session. If you have any doubt, feel free to ask. You can put your comments in comment box. Students, I have also put in description box the link for the document, the link of this question and answers. I will repeat, I have put a link of a document which consists of these answers, the questions that we have discussed today. Okay, so you can click on that link and you can download that document also. Okay, it is there in the description box, so it will be beneficial for you for preparing for your exams. Okay, so thanks for attending this session again. Okay, see you during next session. Until then, take care. Bye bye.